IPSec implements a standard set of cryptographic algorithms that provide secure, trusted connections over TCP/IP and protect and filter the contents of IP packets at Layer 3, that is the networking layer, of the Open Systems Interconnect model. IPSec encrypted packets are resistant to IP MAC spoofing, man-in-the-middle attacks, packet sniffing, denial-of-service attacks, and payload and data modification. To create an IPSec encrypted connection, both sides require a compatible, but not identical, IPSec policy. Compatibility is negotiated through IPSec or Internet Security Association and Key Management Protocol. Once IPSec establishes that both parties involved in an IPSec connection meet a common and compatible set of requirements, a security association or SA is spawned between them. IPSec provides security using the AH or authentication header, an ESP or encapsulating security payload. AH provides authentication, integrity, and anti-replay capabilities, but does not encrypt the payload. ESP further provides confidentiality by encrypting the payload. Like a sophisticated firewall, IPSec policies can filter and control packets based on source and destination IP addresses, protocols, and ports. IPSec implements peer authentication through Kerberos, pre-shared keys, or public keys. In other words, it identifies an entity before connecting to it via a security association. IPSec manages these keys and provides for their exchange and a secure means of updating them. IPSec provides data origin authentication to prevent a spoofer from intercepting packets and posing as the sender. To accomplish this, each IPSec encrypted packet is assigned a checksum known as an ICV or integrity check value. This ICV is an HMAC or hash-based message authentication code. Simply put, a hash is a one-way encryption algorithm that takes an input source of various links and produces a fixed length digest. Keyed hashes include secret, shared, private, or public keys in their calculations. If the sender cannot calculate the correct ICV, HMAC, and hash, then the receiver rejects the packet. In addition, data integrity and data confidentiality are protected via checksums. Furthermore, IPSec clients are protected against replay attacks. That's where traffic is captured by a packet sniffer and replayed later to mimic security associations and spoof surfers, by a unique sequence number given to each encrypted packet. IPSec can be configured two ways. The first is tunnel mid. This protects gateway-to-gateway connections across the internet. The second method is transport mode, and this protects clients using the same authentication protocols and compatible IPSec filters, usually on a local area network. IPSec security associations are initiated by a collection of encryption algorithms known as the cipher suite. This initial negotiation of protocols and algorithms is also protected after the first negotiation is transmitted in plain text. Why unprotected in plain text, you might ask? Well, since encryption is not possible until both clients have decided upon compatible algorithms, the first time it has to be unencrypted. IPSec security associations are established via the IKE, that is the Internet Key Exchange, which combines SA negotiation via IPSec and the use of OKDP, that is the Oakley Key Determination Protocol, to generate a secret key. ODKP uses the Diffie-Hellman algorithm to determine a secret key that will later be used for encryption by first exchanging unencrypted information between clients. Again, this is necessary because until both clients possess a secret key, no encrypted communication can be sent. A typical IPSec policy is comprised of 1. The tunnel setting, that's the IP address of the tunnel endpoint, 2. The network type, which could be all LAN or remote access, 3. The IP filter, based on the IP address, port, and protocol, 4. The source address, as defined by the filter, 5. The destination address, as defined by the filter, 6. The IP protocol, also defined by the filter, 7. The IP port, again the filter, 8. The IP filter list, which is the combination of all IP filters, 9. The filter action, which is permit, request, or require, and finally 10. The authentication method, be it Kerberos version 5, certificate, or a shared key. Typically, to configure an IPSec policy, you'd add the IPSec Security Policy Management snap-in to a Microsoft Management Console, you'd create a new IPSec policy, a new IP security rule, a new IP filter list, then a new IP filter, and specify an IP filter action. Finally, you could assign the completed policy to a computer or a group of computers. Let's take a look at IPSec and IP security policy. The first thing I want to do is open up a Microsoft Management Console, or Mickey Mouse Console if you prefer. I need to add or remove a snap-in. And in this case, I'm interested in these two. Really only need this one, but I'm going to add IP Security Monitor as well. Make sure you add it for the local computer. I'm going to select OK. And then of these two here, I'm going to go ahead and right-click and say Create IP Security Policy. I'm going to go Next, and I'm going to call this the Galactica IP Security Policy. And keep the Cylon boogers out. Activate the default response rule, not necessary, but for backwards compatibility, I'll check this option. And then I'm going to go through this wizard here, default response rule authentication method. I'm going to go with the default Kerberos version 5. It's typical for Active Directory. And I do want to edit the properties, so I'm going to click Finish. Okay, so I'm making myself an IP security policy. And as I walk through the wizard, in that IP security policy, I need to configure some rules. So I'm going to go through here, and this is the default response rule, but I'm going to add another one. So I'm going to create a new security rule to my new security policy. I'm going to select this option. This rule does not specify a tunnel. It's connection oriented. Otherwise, I'd have to go here and actually type in the IP of the tunnel endpoint. But I'm going with the default. And I'll select all network connections. And in this case, select the IP filter list for the type of IP traffic to which this security rule applies. And I could select here this IP filter list, or I could add another one. And then I could just say and then if I do that, welcome to the IP filter wizard. I would click Next, and IP filter description. And it'll be mirrored. And I can specify the source address. I'm going to specify my IP address. So I'm the only source. Destination address would be any address. Select the protocol type. I'm just going to limit it to transmission control protocol. From any port to any port. I mean, alternatively, you could specify a certain port, FTP 2021 or HTTP 80 or something like that. I'm going to select Next, and I'm going to click on Finish. Okay, and then of my list here are my IP filters, my IP filter list. And if I wanted to, I could add, add another IP filter. I don't know, we'll call this one search. And again, I'm going to say my IP address and any IP address, and I'll limit this to user datagram protocol this time. From any port to any port is fine, and then I'm going to go ahead and click Finish. Okay. So I have two filters here on my filter list object. I'm going to click on OK. And then for the security rule wizard, I can select either one of these now. The Galactica IP filter list or Galactica Prime IP filter list. But again, I would click Next. Now I have to specify an action. So Galactica filter action, if that wasn't there, I could go ahead and specify Galactica Prime filter action. And just little comments there. Notice that I could choose permit, block, or negotiate security. Choose permit, and then I'm going to go ahead and finish. Okay, so either one of these could be filter actions that I could specify. I'll go with the new rule, and then click on Finish for completing the security rule wizard. And then once I do that, notice that over here I have Galactica IP filter list, and then over here, just sort of my default response rule. And I can click OK, and once I do that, this is my policy here, and I can assign it, and I can unassign it. If I don't like it, I can get rid of it. And if I want to, I can create a new IP security policy. So several different options there. That's just kind of maybe walking you through showing you the ropes of making an IP security policy and configuring just some of the many settings of this Active Directory and Windows feature. Note, unlike 2003 where IPSec and the Windows firewall were separate and often conflicted with each other, in 2008, IPSec and the firewall are integrated with each other. IPSec has 4 connection security rules. 1, an isolation rule. 2, an authentication exemption rule. 3, a server-to-server rule. And 4, a tunnel rule. The isolation rule restricts or allows connections based on criteria such as domain membership. It is configured with inbound and outbound authentication requirements, authentication methods, and protocols. The exemption rule defines clients that are exempted from IPSec isolation rules and authentication procedures, such as DHCP servers. The server-to-server rule defines IPSec rules between servers or groups of servers. And the tunnel rule protects traffic between tunnel endpoints rather than actual clients. Let's look at implementing some security connection authentication rules. And remember in 2003 that the firewall and IPSec policy management console, they were kind of separate. And oftentimes they would conflict, but they integrated all that together in 2008. So really to do this, we're just going to go and access the Windows firewall from administrative tools. And what I want to do is select connection security rules. And I would select a new rule. And the first one we'll do is an isolation rule. And I can specify request authentication for inbound and outbound connections. I can specify require authentication for inbound connections and request authentication for outbound. And of course, the strongest, require authentication for both inbound and outbound. I'm going to go with the first option, request. I'm going to say next. I'm going to go with computer, Kerberos version 5. Notice some of the other options here if I wanted to. I could do both the computer and the user. Or I could use a certificate from a certificate authority, but that'll be another, maybe another session there. I'm just going to go with Kerberos version 5. Notice I could select when does this rule apply, and since this is on a portable, it's a laptop and I carry it around, I'm going to uncheck private and public. This is only going to apply on the domain. And I'll click next, and I'm going to call this Galactica Connection Isolation Rule. And I'll click Finish. Notice there it is. And I can disable the rule, and I can enable the rule and delete it. And of course I can go to Properties. If I wanted to modify any of these, I could. I could modify the authentication protocol, but that's looking at an isolation rule. Now let's look at another type of rule. So again, I'm going to highlight Connection Security Rules. I'm going to click on New Rule. And this time I want to do an authentication exemption, whereas this governs in and outbound connections. This governs exemptions to those connections. And I'm going to add a remote computer, and I could specify the IP of a specific certain computer. I could specify a range. If I had servers with static IPs in a certain range, I could specify a predefined set of computers. So my router, DHCP, probably don't want to apply too many rules there because everybody needs DHCP. In this case, I'm going to select DNS. Again, another vital Active Directory service, so that would be a good candidate to make an exception to my isolation rule. I'm going to say next, and once again, this is on a portable machine, so it really only applies when I'm logged into the domain, not when I'm on other networks and things. So I would untick these options. I'm going to click next, and I'll just call it Galactica DNS Exemption Rule to exempt my DNS servers. And again, same thing. Notice I could enable, disable, look at the properties on it, change it, that kind of thing. The IPSec policy agent requires information about IPSec policies and passes this to other IPSec components. It also searches for any changes to IPSec policy configuration. The IPSec policy agent checks every incoming and outgoing packet against the filters in its list. To do this, it uses the IPSec driver, which receives the active IP filter list from the IPSec policy agent. When an outgoing packet matches the filter list, the IPSec driver initiates the IPE process to negotiate security with that packet's destination address. If the security associations and keys match up and the negotiations are proper, The IPSec driver signs and encrypts the packet and sends it to the destination address. If things do not match up properly, the IPSec driver rejects the packet. IPSec processing can be negotiated two ways. The first, Oakley main mode, will determine the encryption key and security for encrypting main or quick mode communications that follow, initially creating the IPSec MP security association. The second, Oakley quick mode, determines how traffic will be secured and encrypts data using a previously created IPSec MP security association. You can deploy IPSec via local security policy on a standalone server or via group policy in Active Directory. Let's take a look at deploying IP security and IPSec policies. And often that's done through a GPO or group policy object, so I'm going to open up a Microsoft Management Console, and I'm going to go ahead and add a snap-in. And what I'm looking for is Group Policy Management or Group Policy Management Editor. In this case, I'm going to choose Group Policy Management. I'll add that in from my domain. And I'm going to open up my forest and go to my domain, battlestars.galaxy, and look at my default GPO. So there's my default domain. Don't forget the nag message. I'm going to edit my default GPO. Yes, we know that affects all computers in the domain. And notice I have two options here, computer and user. I want to choose computer. I want to choose policies. I want to choose Windows settings. I want to choose security settings. And then when I go down here, let me pull this over here to IP security policies, and I'll just kind of expand this so you can hopefully see everything. So IP security policies in Active Directory. If I wanted to, I could make new policies. However, notice there are 3 built-in policies, and I'll drag these columns over so you can see everything. I'll drag them over a little bit more. Boy, Microsoft's a little long-winded there. Alright, that's good enough. So there's client, respond only, secure server, which is require security, and then there's server, which is request security. The weakest one of these guys, in this case would probably be client, respond only. And then the strongest one would be to require security, and then sort of an intermediate, in the middle there would be request security. And so how does that work? And this just responds only. I mean, if a secure SA is requested security association, it can respond if it's got the correct protocols, and it can authenticate and encrypt its data accordingly, but it doesn't seek it. It never asks for secure connection. This is like, you're running like in a hyper-paranoid environment, and it absolutely requires security all the time for security associations or SAs from both ends on all IP traffic. And this is sort of the intermediate, or in the middle there, and it will request security, but if it can't negotiate a compatible set of protocols at the other end, it will allow insecure, or unencrypted SAs. And if we were to take a look at these, they have, again, default rules that are built in. Notice the authentication methods, in this case triple death, and cancel out of there. Let me go over here. I'm just looking at some of these default settings for the tunnel endpoints. This is, we're using Kerberos. And then let's look at request. And, Kerberos on the default rule there. And then if I wanted to, I could assign, policy assign yes, see, or I could unassign. And this can have a profound effect on the way my servers communicate with clients in the network. If they don't have compatible IPSec policies, and they're not using the same, depends on what I'm using, a certificate or a pre-shared key or Kerberos, then me setting this can very easily make it so that my server cannot no longer communicate with anybody else on the network. So, a bit of caution, or take care to make sure that your IPSec policies are compatible once you assign them in a GPO and then apply them with a GPO update. Permanent IPSec policies are called persistent policies and are stored in the system's local registry. Persistent policies combine with Active Directory group policy and local policy, but when there is a conflict, persistent policies are dominant. Whenever persistent policies are changed, the IPSec service must be restarted to reflect those changes. When combined at different levels, IPSec policies are applied in the following order. First, local, then site, then domain, and then organizational unit. When deploying IPSec via a group policy object, you may choose 1. Client, respond only, 2. Server, request security, and 3, secure server or require security. These are listed in order from least to greatest. So in other words, client respond only would be the least secure, and secure server require security would be the most. Let's break this down and take a look at the first option, client or respond only. This setting does not initiate secure connections, but will respond with the requested protocol if it is solicited. This is typically used on clients that do not normally send secure data. The next option is server or request security. When configured with this option, clients will attempt to initiate secure connections with every host. However, if a secure connection cannot be negotiated, then non-secure connections are allowed. This policy setting requires Kerberos version 5. The strongest of the three options is secure server or require security. This mode of operation requires a secure connection to be negotiated by the IPSec security agent, or subsequent connections will not be allowed. If IPSec security requirements are not met, the driver agent simply drops the packet and rejects the connection. Again, please note that clients with incompatible IPSec policies will not communicate with each other. You must factor this into your daily troubleshooting and diagnostic routines when clients lack connectivity, in spite of good physical connections, clean ARP and DNS caches, and compatible IP addresses. Also remember, there's no free lunch. Protection comes at a cost. IPSec will significantly reduce server and bandwidth performance due to its encapsulation, encryption, and decryption activities. IPSec activity can be monitored via the IP Security Monitor snap-in in a Microsoft Management Console, or by utilizing the netshow command line tool. Here are some tested and functioning examples of syntax using the netshow command. For example, netshow IPSec static show filter list name equals banana would display the specified filter list, specifically the one called banana. Netshow IPSec static show GPO assigned policy name equals banana would display the policy assigned to that specific GPO. Netshow IPSec static show policy name equals banana would show that specified policy, and netshow IPSec static show rule name equals banana policy equals apple would display the rule of that particular policy called apple. Here are some tested and functioning examples of using the netshow IPSec dynamic show command. For instance, netshow IPSec dynamic show config would display the IPSec configuration and bootup behavior. Netshow IPSec dynamic show MMSAS would display the main mode security association and its source and destination IPs. Were I to tack on resolve DNS equals yes to the end of that previous command, I would get the same results, but it would also display the host names. If I were to use netshow IPSec dynamic show QMSAS, it would display for me the quick mode security association. And if I were to utilize netshow IPSec dynamic show stats, it would display the IKE. Here's another example. Let's say I wanted to log my IPSec activity. I could use the command netshow IPSec dynamic set config property equals IPSec diagnostics value equals 7 to log everything, value equals 0 to completely disable logging, or in between 1 and 6 would give me different levels of logging activity. While we're getting carried away, here are some more netshow commands. They don't really have anything to do with IPSec, but I thought I'd throw them in. These are netshow interface commands, and you can do cool things with them too, such as netshow int IP show config would show the IP configuration, sort of like IP config all. Netshow int IP add would add an IP, netshow int IP delete would delete an IP, and netshow int IP reset would reset your TCP IP stack. Still other netshow commands involve the WinSock, such as show catalog and reset catalog, which can repair your WinSock. When TCP IP and your WinSock gets really fouled up, netshow is a good command to know. Netshow firewall show and firewall set, well, it does what it says it does. So while we veered off on a tangent talking about the supercalifragilistic netshow command, let's refocus for the ending. Just remember, IPSec is a great way to provide secure communication between clients on your network.